Hi everybody, I wanted to talk to you today about a method for solving quadratics when they don't factor. So let me show you an example of what I'm talking about so you can kind of get an idea of the background here. Look at this quadratic, 5x squared minus 10x minus 45 equals 0. If I try to factor that, first thing I'm going to want to do is take out my GCF. So I'm going to take out that 5, divide across by 5. Okay, and I have this. All right, so then I'm going to try to factor. Well, a times c, 1 times -9 is -9. And the factors I have there are 1 and 9, and 3 and 3. And no matter where I put my positive and where I put my negative, there's no way to come up with a -2. So I have run into a problem, and that is the same problem that was faced by Persian mathematician Muhammad al-Khwarizmi in the 800s AD. He realized that there was a solution. This one did have an answer, but he couldn't find it using any of the methods that he already knew. You can't factor it. It's not in the right format for the square root method, but somehow if we could rearrange it, here's number 6 off of Miss Idstein's video yesterday. If I could rearrange this to be like this, or even better, if I go ahead and subtract 3 from both sides and rearrange it to look like this, then I can solve it using the techniques that I learned yesterday. So I just need a method that will help me take this and rearrange it to look like that. And that is what Al-Khwarizmi came up with. The method that he came up with is called completing the square. And when Al-Khwarizmi was alive, algebra was thought about in a very geometric sense. So his first instinct was to do this using pictures and using geometry. So I want to show you what his idea was. Well, he took a rectangle. This rectangle happens to be a square, and the length and the width are both x. And then he took another rectangle and made the base b. You can see it's b units long on both the top and the bottom. And this side is x units long, just like that one. So if I wanted to, I could put those together because they're the same length. Now he took that smaller rectangle and he divided it in half. So that means that the length of this part is 1/2 b and the length of this part is 1/2 b as well. Same thing up here, 1/2 b and 1/2 b. Now, if I take and I cut that on the dotted line, cut it directly in half, then I can attach it onto the original square that I had. So this piece and this piece both match up fine because remember that length was x. Same thing right here, but it doesn't make a complete square. Something is missing. So that's where his method got the name. It's called completing the square because what you're going to do literally is put something right here in the top that will complete it and it will make a final square. So let's look at the area of this. If we take this and look at the area of each of the 4 pieces separately and add them together, then what we'll have is the area of the whole rectangle. And this was the idea behind Al-Khwarizmi's work. So he said for the big square here, the length and the width are both x, and you remember from geometry, x times x is x squared, length times width is the area of the rectangle. And on the smaller rectangle here, this piece is x. I'm sorry, this piece is x, and this piece is 1/2 b. So again, length times width, just like you learned in geometry, 1/2 b times x is 1/2 bx. That's the area of this piece. This piece is exactly the same, 1/2 bx, because we cut that bigger rectangle in half, and so each piece should be the same size. Now we have this smaller square that we completed over here to figure out. Well, if this side is 1/2 b, then the side of the square up here is 1/2 b. And if this side is 1/2 b, then the side of the square over here is 1/2 b. Length times width, 1/2 b times 1/2 b is 1/2 b squared, because they're the same, right? 1/2 b times 1/2 b is 1/2 b squared. So if I want the area, I can just add these 4 pieces together. So x squared plus 1/2 b plus 1/2 b, oh, I forgot my x, sorry, 1/2 bx plus 1/2 b squared. Well, I see that those two in the center are like terms. Let's add those together. 1/2 plus 1/2 is 1 whole. So x squared plus bx plus 1/2 b squared. So this expression represents the area of this entire square by adding up all the little pieces together. But that's not the only way we could find the area. We could also just use the formula for the area of a square looking at this outside part. So if this piece is length x and this piece is length 1/2 b, then that whole piece, that whole side has a length x plus 1/2 b. And the same thing would be true on this side. If that part is x and this part is 1/2 b, then that side is also x times 1/2 b. So if I want to find the area, length times width from geometry, I would have x plus 1/2 b for the length and x plus 1/2 b for the width. And I realize those are the same, so that's going to be x plus 1/2 b squared. Okay, so let's analyze what we have found here. I have found the area of the square two different ways, but I know that this area and this area are the same because the squares were the same. So that means that this expression for area, x squared plus bx plus 1/2 b squared, and this expression for area, x plus 1/2 b squared, must be equal to one another. Oops. Must be equal to one another because they represent the same amount of space. It's the same area. So those two must be equal to one another. Okay, so now let's go back into our algebraic problem and let's put that geometry with it. So let's suppose we had this polynomial, x squared plus 10x minus 39 equals 0. All right, so here's our quadratic. We're trying to solve it. I see an equal to 0. So if we were to create some rectangles that represent this, I have the x squared right here, and I have the 10x right here. And if we go ahead like we did yesterday and put this to the other side, we're going to get x squared plus 10x equals 39, which is what you see represented in our picture right here. Okay, now let's take Al-Khwarizmi's idea and create some rectangles. So the x squared is right here. The 10x, remember we cut the longer rectangle, the skinnier one, in half. So instead of being one whole 10x, I have 5x here and I have 5x here. And what I'm going to want to do is I'm going to want to complete this part of the square right here. Well, I need to figure out what the dimensions are for that part of the square. So if this square is x squared, its area is x squared, that means the sides must be x and x because x times x is x squared. Base times height, length times width is x squared. Well, if this side is x, and I know that this side times this side, length times width is 5x, well then this side must be 5. And the same thing with this one. If this one is x, and I can multiply length times width, x times something is 5x. That something must be 5. Well, if this length is 5, and also this length is 5, then the area of that box that I added on there is 25. So if I add an area of 25 to the left-hand side, I have to add that area of 25 to the right-hand side as well, which gives me this. I have added 25 on the left, and 39 plus 25 is 64 there on the right. So then I can see this length, oops, turn my pen back on. This length is x plus 5. This length is x plus 5. So what I have is x plus 5 squared equals 64. And then I can use the square root method that we learned how to do yesterday. Okay, let's practice. So let's take this one. X squared plus 4x plus 8 equals 17. Okay, so I'm going to need a space right here so that when I complete my square, I have a spot to put the number. So I'm going to subtract 8 from both sides. I get x squared plus 4x plus something equals 17 minus 8 is 9. And I'm going to add whatever that same something is over there on the right. Because remember, whatever you do to the left-hand side, you have to do to the right-hand side as well. So I just have to figure out what goes right here. Okay, so let's take the idea of the squares. All right, this x squared, that's going to go here. And the 4x, remember the 4x was the whole long rectangle, and we cut it into two pieces. So I have 2x right here and 2x right here. So the dimensions of the square, if it's x squared, then this piece and this piece must both be x. And if this one is 2x, and I know this part is x, that means this part must be 2. And the same thing here. If this part is x and the area is 2x, then this part must be 2. So if I want to fill in, I want to complete the square, this piece is 2. This piece is 2. 2 times 2, the area of this piece is 4. So what I've done here is I've added on an area of 4, and I have to add that same area of 4 to the right-hand side. Okay, now remember how Al-Khwarizmi wrote this. Then he looked at the larger square and he said, well, this side is x plus 2. And this side is also x plus 2. X plus 2 times x plus 2 is x plus 2 squared. 9 plus 4 is 13. So if we factored this one, we have set it up on purpose to be a perfect square trinomial. This would be, its factors would be x plus 2 and x plus 2, which would be x plus 2 squared. 9 plus 4 is 13. Now we have it into a format where we can use our square root method like what we did yesterday. So I'm going to save that for tomorrow's video. For today, I just want to practice what the setup looks like and why it makes sense. All right, let's take this one. So I automatically notice a difference with this one. If I want this square down here to be x squared, I can't have a 3 right here. I can only have an x squared. So I always am going to want this coefficient to be a 1. So the first thing I'm going to do is I'm going to divide across by 3. Remember, you have to do that to every number. So I've got x squared. So 24 divided by 3 is 8. 18 divided by 3 is 6. And 0 divided by 3 remains 0. Okay, so now I've got the x squared, which is what I need to go right here. I need a blank to put this area. Okay, so let's subtract 6 from both sides. X squared plus 8x plus blank, because I got rid of the 6. And on this side, 0 minus 6 is negative 6. And I'm going to have plus blank on that side as well, because whatever I do to the left, I have to do to the right. Okay, so 8x is that whole long rectangle. I need to cut it into two pieces, 4x and 4x. So if this square is x squared, then I know the length and the width must both be x. If this piece has an area of 4x, and I already know that this side is x, well, x times what gives me 4x? This side must be 4. And then the same thing with this one. If this side is x and the area of 4x, x times what gives me 4x? Well, that's a 4. So I'm going to complete the square. If this side is 4 to match this one, and this side is 4 to match that one, then this area must be 16. So what I want to fill in the blank is a 16 on both sides. All right, now let's use our other method of looking at a square. This whole side and this whole side, that's going to be x plus 4 times x plus 4, which is the same thing as x plus 4 squared. Negative 6 plus 16 is 10. And now we're ready to use our square root method, just like we learned before. All right, so I'm going to stop for right now. Hopefully this will give you a good visual to use when you learn about completing the square algebraically tomorrow. You can keep this idea in the back of your mind. And if you want to draw these pictures, some of my students found that to be very helpful last semester. You can draw those pictures along the side if you want to, if that'll help you to keep your thoughts organized.